Thanks for being here. So this is very exciting for me. I graduated from Brock 20 years ago. And I'm not sure I did anything special there, but I just graduated. But it was great. Coming back and just walking through the hallways brings back quite a few memories, so it's pretty cool. So I actually went to, I don't know if I can use other universities' words here. I went to McMaster for the first year. So my parents lived in Niagara Falls. I used to live in Niagara Falls, and then just like any other kid, I want to go away. So I went to McMaster for a year, and at the time I wanted to be a very big businessman. So I said, I'm going to take commerce. But as I went there, and my first semester, I did have a computer science course, and I learned within the first 4 months that I would rather be sitting working programming on a computer than anything else. So halfway through the year I switched and I went into computer science there. And then I've been married for also 20 years. And I met my wife in Niagara Falls, so she was here. And I'm like, you know what, I can't stay away, so let me go back home. And that's how I came to Brock. But the cool thing about that was I took computer science at McMaster and I took computer science here. And I can tell you that the program here was so much better. All I saw, it was amazing. And I'm not just saying that, but at McMaster, it was a very different program at the time. And I don't think that's actually their strength. But when I came here, it was a really good program. So I enjoyed it a lot. It helped me be where I am today. So thank you to all the professors for that. But so my role is so IBM Canada. I manage all of IBM Canada for research and development. It's 5,000 plus people. It's the biggest IT company in Canada. So that is the reason I tell you that, because you can see what's possible, the art of the possible. And I don't want to talk a lot about me, but given the fact that I graduated from Brock, I do want to talk a little bit of how I got to where I got to and how Brock has helped me get there. So you guys should all be proud of being at this school. I remember 20 years ago, when I was in computer science, there was no co-op program. I don't know, I think there is now, right, for computer science. So I did my first year. And then I said, okay, I need to find a job. So in the summertime, I applied, I don't know, hundreds of companies just to get a 2-3 month internship. And my first job was actually, I think it was Niagara, St. Catharines. It was a media company, just data entry. So I was inputting data into the computer. It's nothing to do with programming, but it was a computer in front of me. So that was good. Second year, I applied, again, hundreds of companies in Toronto. And I ended up, I think the second company was Bell Sigma, which is part of Bell Canada. I don't actually know if it exists anymore, but they were managing their entire IT infrastructure and also innovation for Bell Canada. So it was pretty cool. And they put me into the basement. So second year, I was actually by the Eden Center downtown, for those of you who know Toronto. And they had a building right attached to it. They put me in the basement with another student. And our job was to go around, pick up all the old computers, bring them to the basement, take them apart, and build better ones as much as we could from the old parts. Of course, again, nothing to do with programming, but I learned a ton about hardware that summer. It was pretty amazing. So of course, I did the same thing after the third year. And then I ended up at a company called NetTest, which network testing equipment. And I did my internship there. They loved what I did. I loved what I did, and they offered me a full-time job. I was there for 7 years. When I took that job, the company was about 2,000 people. Most of it was actually based out of Europe, but I was in the Markham in north of Toronto office. And that company went through the hard times in the early 2000s. But I worked super hard. I loved what I did. Within 2 years, I was a manager. By the time I left 7 years later, the market had kind of started going down, but I was already heading all of development for the VP of development. And with a downturn, they went from 2,000 down to 50 people. So, which is not a great story, but I was going to shut down the company, and I did not want to do that, so I decided to move. I went to another company called Data Mirror, which was data replication. And I was there for a couple of years. I headed all of their quality assurance and infrastructure teams. I was only there for 2 years before IBM decided to acquire that company. And the first 2 and all the internships I did were pretty small companies, except maybe Bell Sigma. And I actually enjoyed the small company feel. So in my mind, I'm going to go to IBM, I'll put it on my resume for a couple of years, and then I'll go look for something else. That was 12 years ago. And the opportunities that I've had there have been amazing. So I've really enjoyed that. But more importantly, the message I would like to give you guys is really about what you guys can do. Take the ownership, take the initiative, work hard, and drive innovation. And at IBM, I am now part of the data and AI group. So I manage a $2 billion product or portfolio. A lot of the products in there are around data and AI, which is actually why I'm here. I'm going to talk about today. All right, so that's all about me. It's been a great journey, and I'm happy to be here today. I'm happy that this conference is happening, because one of the biggest gaps that we have in the market today is skills around data science and machine learning. There's a 100% shortage. If you go in that field right now, you will get paid a lot of money. If that's one of your interests or your goals, get into data science. All right, so let me talk about data and AI. There was a video here that we couldn't play, but most companies in the industry have realized that data is a key component of everything they need to be able to do a transformation. However, only 15% of those companies realize or can leverage the data that they have to do what they need. So that's a huge problem. When we look at data, when we look at machine learning and data science, it's not just a narrow view. We're actually looking at end-to-end. And I'm going to talk about that today, because to be able to get the insights you need and apply machine learning and data science or AI, you need the end-to-end. You need to be able to collaborate between data scientists, data engineers, data stewardists, application developers, line of business who understand the problem in the industry that you're working in. So it's a collaboration. Data is 100% the #1 ingredient for that. A study from Forrester says 90% say improving the use of data is a top priority. So good. I think the industry has realized that that's 100% important, and that's a good step. 71% have a plan to build a system that is insight-driven to become more competitive. So that's great as well. This is what we call the maturity curve. Okay? Most companies in the past, most companies have started here. It was all about operationalizing what they had, cost reduction, so they put systems to be able to reduce that. They shifted over to what at the time they called modernization. Obviously, every time we do something new, we're modernizing. That was business intelligence, data warehousing, which still happens quite a bit today. We're shifting now to what we call service analytics to be able to get more insight-driven information. Most users, most companies are right in the middle of that as they're trying to shift and push towards to the right. The end goal is new business models, which again is called transformation. But in this case, the hot topic is exactly machine learning, data science, AI, on how we get there through the use of data. 85%, this is from MIT Sloan, view AI as a strategic opportunity. So that's how important it is. So to my point earlier about being an end-to-end, there is no AI without an information architecture. And I'll explain why in the next probably 10, 15 minutes. But at a high level, what's machine learning? You have data, you have historical data, which is a fundamental ingredient for machine learning. You take that data and you feed it into mathematical algorithms. The output of that is what's called a model, okay? You take that model, you put it into a production system, you execute against that model, that's called scoring of the model. There's no amount of algorithmic sophistication that will overcome the lack of data architecture. What does that really mean? It doesn't matter how good your algorithms are. If your data is not good, if your entire end-to-end infrastructure is no good, your predictions, your intelligence, your insight are not going to be accurate. So that's a really important step. 81% do not understand the data that's required for AI. So big problem. So this field, even though machine learning has been around for 50, 60 years, it's still fairly new into its journey. We're actually at the very, very beginning. And a lot of people don't actually understand it. 80% of the data is either inaccessible, untrusted, or unanalyzed. So when you think about large companies, right? Take IBM, for example. 400,000 employees worldwide. We have acquisitions that the company has made, different business units, different groups, sales, support, development, marketing, finance. Every single one of those groups has data everywhere. If I'm trying to build a 360 view using AI of any of that information, I can't do it unless I have the right information architecture, because I don't have access to the finance system. They don't want me to see their numbers, right? Marketing has their own system. Support has their own system dealing with tickets coming in from customers when they're having issues with the product, right? So it all needs to come together. That's the right information architecture. That's how we can make smart decisions. Here's what happens when you don't have the right information architecture.
Customer data. You got tons of it, and you know your customer. Take Jack, for example. Jack loves waffles. How do you know? Because Sunday Jack said so on social. And last Friday, he'd been searching for a waffle maker in your online store. Boom! Now you're ready to talk to him. Because you know Jack. Except, Jack was actually just carving up for a 5K at the end of the week. He's not so much a waffle freak as a fitness freak. But you already assigned him to a target audience, so you're still talking to him about all things waffle. Jack deletes the email without opening it. And then he ignores your SMS. And closes your ad. So you don't know Jack. And to give Jack an experience that would have actually been right for him, you should have had an AI-powered platform that connects all your data to show that he's not obsessed with brunch, he's obsessed with running. And you also would have known that Jack is actually Jacqueline.
This happens all the times. We all probably get spammed with emails that have nothing to do with what our interests are. And if you're in marketing, that's a huge problem. You've just lost all the work that you've done sending a promotion or an offer or anything to somebody that doesn't care, right? So that's how critical. That's just one example. But this can happen in any part of the business, any industry, and it's a huge problem if it's not done right. So here's what we have defined as the right ingredients and components for the right architecture. And everything, if you start from the bottom up, everything starts with data. It is the #1 ingredient for everything. And being able to access that data, as I talked about, for example, in the different parts of the business, and even outside, social media data, bringing that in, weather data, all of that data is super important to making important decisions, the right decisions. So that's the collect phase. How do we access that? The next one is organize. So, okay, great, I have data. Again, in a large enterprise, you want to be able to manage that data. You want to be able to provide the right access control, policies around privacies, things like GDPR, right? All of the things are critical to be able to provide the right access to the right users, right? So that's the organize phase. Analyze is really where the machine learning, AI, insights, analytics components take place. That's really where all the brains taking all the data together and bringing it in and driving those insights. And the last one, which at the top of the scale is the most important one, is where you can infuse machine learning models that you've built, AI models, into your applications, into customers' application, to be able to actually leverage that insight that was generated. So that's what we call the AI ladder. It's top to bottom to be able to access all the way to insight and then infuse those insights into the application. So what we've done is we actually released a solution called Cloud Pak for Data, which does all of these things. So if I look at the collect phase a little bit deeper, it's really about accessing that data, right? Data virtualization, I'm not sure if you guys are familiar with that. It's not actually a new technology, but it's coming back into the market really strongly right now. And the reason for that is because, as I mentioned before, data is everywhere. And what we used to tell our customers and what we used to do in the industry is try to bring that data together from different, if you look at, for example, Hadoop, that's exactly what Hadoop has been trying to do, right? That big data lakes. You take data from everywhere, you bring it into one centralized location, and then generate insight out of it. We no longer do that. That actually doesn't make sense because there's delays, there's security problems, there's new infrastructures, there are different skills required to manage different systems. There's so many things that go against that. So the goal now is leave the data where it is. It's really about data gravity, and we bring the tools to access that data where the data is. So that's what Collect is all about. Organize data. Okay, so I have data in all these different places now. Being able to search for the data. Most companies leverage less than 15% of that data to make decisions. That means at best, they're making the wrong decision, right? That's a huge problem. So that's what the organized piece helps with, discovery and search of data, right? Applying policies, cataloging, and we apply machine learning. I'll talk a little bit about that as well as we go through that. And analyze, again, like I mentioned before, is really where we build the machine learning models, the AI, the insight on that data. We do dashboarding, reporting, visualization on that data, which I can talk a little bit more about that as well. So that's our platform, which is really geared towards the AI ladder that I talked about. So going a little deeper in the collect phase. So I talked about data virtualization, which is a key component. The other one is, I mean, we all know what's going on in the market around different clouds. IBM has their own cloud infrastructure, Amazon, Azure, Google, Alibaba has their own, right? Data is everywhere. However, one of the key things as enterprises are building their solution is they have teams, they have data on-prem, on a private cloud environment, they have a hybrid, they have public, they're on different vendors, right? So being able to have a common, what we call SQL engine to access that data is very critical. So that's one of the things we drive into the market. Data warehousing, IoT, which I saw in a previous slide as well. We put AI right into the collect phase, right? We make decisions through machine learning as we're accessing the data to make that data access easier, perform better. Those are all critical aspects. Even as an end user, as you're using an application on your phone, you're relying on very heavy infrastructure in the background. When you do a banking transaction, by the way, I don't know if you guys know, every time you use your phone, you're 100% guaranteed to be going through an IBM system. I don't know if you guys know that. Every single transaction that you do. So that's very critical, right? To be able to provide that type of intelligence insight at every single step, including at the collect phase. Everything that we do has to be cloud native, elastic, resilient. That's very critical. And then the other most important component that I'll talk about here is open source. I think you guys all know what open source is. Yes? I hope. But open source is really community-driven innovation, right? And there are a lot of products in the market that are open source based, and we bring that into our platform. It's not about making one proprietary solution. It's about being open, and that's what we do. Organize data. So I talked a little bit about the data access, data search, being able to catalog the data. In this particular case, for example, what we do is, as we're accessing that data through, let's say, data virtualization, as an example, we're actually understanding the data. We're applying machine learning models, like, for example, classification on that data. We are then applying, we're building metadata based on the type of data. We're doing automatic cleansing on that data. I don't know if you guys know, Any data scientists in the room? So as we did design thinking to understand what the job of a data scientist is, we actually found out that 80% is spent on data cleansing. The data is not good enough for me to feed into these models, into these algorithms. And that's a huge problem. So we took that and we try to automate that as much as possible, right? Because data most of the times is either entered by humans or some system that potentially doesn't have the full data in there. So we try to automate that as much as possible and do that work so the data science doesn't have to spend time doing that. So that's the organized piece. I'll try to move a little quicker here because I don't want to take the whole day. But Analyze is really where we build machine learning models. We have a tool in this platform, which hopefully some of you would have heard about, called Watson Studio. So it's part of our big Watson brand. Watson Studio specifically created for building machine learning models. It takes the open source technology that I talked about, like R, Python, which Python now is the #1 language in the world, but more specifically for data scientists. And we integrate that with our own research technology. And then what we do is we provide capability to be able to move that, to apply these models into an enterprise world, put them into production. Talking to some of the large banks, putting a machine learning model into production in the past would take them 9 to 12 months to do. So I'm building a model on data that's happening today, but I cannot apply that insight into a production environment for 9 months. So think about that. By the time I do that, the data has totally changed. It won't be useful to me anymore, right? But that's what used to happen. Now with tools like Watson Studio, you can put a model into production in a second. You just right-click and say deploy. That's how quick it is. It creates a secure web service, REST API, fully authenticated, that you can score in real time. And it all happens within a second. So it's pretty amazing. Predictive analytics. One of the things that's very critical in the market today around, or in the industry today, around machine learning is the trust. That's a big new problem that's surfacing. And there's a lot of skepticism out there. Machine learning, AI, is going to take over the world. It's going to kill us all, right? I was at Bell Canada downtown yesterday, and I was giving a similar type of talk, and that's what they're worried about. That's their fear, right? So part of it is 100% true. For those of you who potentially maybe drive a Tesla, think about it, right? You're driving a car, as you have been doing for many years. All of a sudden, Tesla says the car is automated. So now you take your hands off the wheel. How comfortable are you going to be for the first time as you let go of that wheel? It's scary, right? That's how most users feel about AI right now, because it's automating things that humans have done where there's been security of how it's been done, and now you take that away through automation, through what we call a smarter system, and then now there's this fear that you don't know how it's going to behave. And then people take it to the extreme that it's going to basically take over the world, right? So I think the fear is valid, but one of the things that we're doing to make sure that this is more managed and there's guardrails around all of this stuff, we're building a lot of tools around explainability, bias detection, right? So explainability is really, how do you explain how a model has made a decision? And for those of you who know machine learning, the algorithms are very complex for humans to understand. So if I'm in a business and let's take loan application. Maybe most of you have already done that for your student loans. And the bank says approved or declined. The banks, and I think we have someone from CIBC here, the banks will get audited on a regular basis to make sure that they've taken the right steps, followed process, have been fair to their customers. All of that is very important as we protect consumers, right? When an audit happens and they say, how did you approve this loan, or how did you decline this loan? You can't say, oh, the machine learning model told me to do that, right? You can't do that. So we need to be able to provide the tools to explain how those decisions were derived. with these complex algorithms that we've now selected to use, right? So we've built that. We actually made that open source. It's available for anyone to use because we believe some of those things are very critical for the market, for every user to actually leverage. The other one is really about bias detection. Let's take that same loan application example. What if I were to tell you that, for example, loans applications come in, there's a higher chance of males getting approved versus females, right? That bias is actually built into the data that we have. That data was built by us, humans, based on our own cultural beliefs that we've had during our history. So the bias that's happening in machine learning is actually caused by humans, by us. We're the ones that introduced it. So we're actually bringing tools to remove and eliminate that. So machine learning AI in this case is going to make us better, right? Machine learning AI is going to make us better in the healthcare industry. It's helping save lives all over the world. So for those people that are skeptical about AI, there's a lot of goodness that can come out of it and will come out of it. The most important one at the end, once you've done all this, is how do you put that into your applications? How do you infuse that into your own processes, business processes as an enterprise? How are we doing on time? All right. So I'll try to, maybe I'll skip some of these just to also allow for some questions. I talked about open source. Everything that we do at IBM leverages open source. We contribute to open source. If you look at this chart, IBM was always number one. I don't know how much you guys have followed in the news, but IBM bought Red Hat earlier this year and paid $34 billion for that company. If you take that part of the chart and put it on top, that's where we are in terms of open source. We're very proud about that because that it's giving back to the community, to even including academia. So it's very important to us. I talked about data gravity, and what I want to mention here is that our tools don't only run on one platform. They don't only run on IBM Cloud. We specifically made decisions to be able to run anywhere because it's important to leverage the tools on where the data is. Again, it goes back to the data. I have some examples here. I'm going to quickly skip through these. These are real customers leveraging machine learning and AI with their data and how they were successful there.
Is reality, where data is unbound, no matter the volume or variety. Where information complexity is made simple and accessible, enabling you to unlock the value of data in new ways. Surface hidden intelligence to transform how your business operates. Predict, automate, and optimize for better business outcomes. Reimagine and easily deploy new business models. DB2 is an intelligence database engine built for scalability and flexibility, bringing together all your data located on premises and in public or private cloud as containers. Eliminate ETL by running all workloads on one copy of data through data virtualization, including NoSQL, Graph, and blockchain. Leverage open source and multi-cloud architecture with the common SQL engine for all of your workloads. It's self-tuning and smart with ML-based SQL optimizer, confidence-based query, natural language query, and embedded model training. The foundation of AI is data architecture. Be ready for everything that comes next with the new generation of IBM Db2. Your data future is about more control, more flexibility. IBM Db2, the AI database. AI starts here.
How many of you know Db2? All right, some. So it's one of the top 3 databases in the market. There's Oracle, there's Db2, there's SQL Server. Those have been the top 3 traditionally. We have just reinvented Db2 for AI. I was talking to Gartner. For those of you who don't know Gartner, they really assess what's going on in the market. Their comment was, there's no AI without IBM. We are the force driving this technology forward, and we're very excited to be doing that. It's available for free on the cloud. All you need to do is log in. Within seconds, you have access to an entire database. You can just load data and go. Great tool for projects. All right, I probably will stop here. The last slide here I had is, these are Forrester is another institution like Gartner that really assess and compare the different solutions in the market. If you can see in each one of these areas, driven by our Watson brand, we're #1 in the market in each one of those in the AI space. So we're very excited, and that's proof of where we are. All right, so I would like to open up for questions.
Thank you, Steve. Could you please talk a little bit about the latest trend of cognitive computing at IBM? Thank you.
Yeah, so we have, I mentioned the whole Watson brand. Watson is not just one tool, but it's a set of tools for cognitive specifically. Natural language processing, natural language understanding, a natural language query for our databases, chatbots, all of that, we have services. They're actually available for free if you go to ibm.com and log in, create an account. All of those are kind of microservice architecture. You, as a developer, you pick and choose which ones you need, you integrate with your application. So there's a lot in that space. And then I mentioned Watson Studio. So if you do want to build machine learning models on top of that, or even including leveraging those services, it's all available there. So we have the most comprehensive tool set in the market around AI.
One of the things that keep coming up when you read about data analytics is the Internet of Things and how the real-time recording of data and analytics of pretty much everything is important. So as a small business owner, and if you want to be ahead of the curve, so to speak, what are some of the low-cost resources that are available to you to compete with bigger companies in that area?
Yep. So as I mentioned, the first thing, all our services at a starting point are all free. So you can actually build your entire application as a small business for free. And as you scale up, then you can start expanding your infrastructure, and then that's when it will start costing you money. But other than that, it's all available initially for free. You can build your entire solution and get started from there. Yeah.
I've heard a lot of people in Silicon Valley talking about data intuition, and I'm wondering, how could mathematics be used to derive emotion, and why would we even bother trying?
So some of those things are always driven by how do we make our jobs easier? How do we make our lives easier? And I don't know if you've seen in some parts of the world, there are already robots or systems walking around that can detect how you're feeling, what your face is looking like. So face recognition, emotion recognition is 100% a reality already today. And the reason would be, for example, if I'm walking into a retail store, right? So retailers would love this technology because they want to see what mood you're in. How are you feeling as you're walking into there? Are you going to spend money? What do you think you may be looking for? So that some of those things can be derived just by looking at the emotions, trying to detect the emotions of how that person is feeling at that point in time. So there's 100%, and that's just one example in retailers, but especially in parts like Japan. I was in California myself a few years ago. One of the hotels has a robot walking around. It's delivering towels, delivering water. It's all automated. The things are walking around. So we're 100% going there. That's happening. And being able to assess us as humans is one of the things that, to the previous questions on what cognitive is going to do, to be able to provide better services to us. That's the end goal in the end, right, is to be able to provide better services to us. And as businesses, what they're looking for is how do they save money or how do they provide a better service. So by putting these robots to replace what a human would normally do, right, is part of that journey. Was that the last question you said? Oh, there was, okay. So, thanks, everyone.